Hi, my name is Mike Cohen. I'm Director of Product Management at Cisco.
Hi, I'm Prasad Velanki, CEO of Convergence.
And today we'll be demonstrating an example of data center SDN using technology from Cisco and Convergence. The scenario we looked at is a large data center public cloud, essentially an OpenStack environment that was designed to run data center workloads on, essentially as infrastructure as a service, but also in a way that enables a really rich data center fabric with strong demands for network services. The challenges the vendor had here was one, to provide essentially a very rich, flexible set of network capabilities, including differentiated network services that they could offer to each of their tenants. They wanted to allow very flexible composition of services across different workloads, and then also allow multi-vendor environment where they could actually swap in different services directly for each of the tenants and dynamically stitch them in an automated way across the fabric. The solution we brought to bear for the customer used a platform called OpenStack Group-Based Policy. So Group-Based Policy was designed to offer an intent-driven interface for OpenStack, essentially capturing the application requirements using what we call rule sets and endpoint groups, where the groups actually define sets of sets of network endpoints that need to be treated the same way. And it also has a construct for defining network service requirements that can be stitched together between these different groups. And it also includes, as part of group-based policy, the ability to do lifecycle automation or allow via plugins different solutions to enable lifecycle automation across these different services as they're created and stitched together. And then it can also use technology for service stitching and chaining. So the solution we actually brought to bear here essentially also was required to do services from multiple vendors. So our customer actually wanted to use a number of different services across different areas and across different vendors, and be able to dynamically manage them and stitch them together. So in this scenario, Convergence actually used their SDN capabilities to manage services and actually provision them and deliver service functions as part of group-based policy. We're also using the Cisco application-centric infrastructure as the base network fabric for this environment, where we can enable a policy-based automation and an integrated overlay and underlay environment across the entire domain. We also tied in a number of network services. We looked at things like Avi Network, Cisco ASA, as well as open source solutions that can be tied in this environment. Prasad, is there anything you want to add?
Yeah, I think one of the key points you have to make is, in terms of the service, the particular customer scenario we're targeting, now with this ability, as Mike spoke, they were able to add now very rich services functionality from multiple vendors, and then they can plug and play each of those, and also have a very kind of a network service UI where the network service vendors themselves can now innovate to provide their kind of secret sauce from a network service perspective. This whole group-based policy allows you kind of do that and enables that.
So let me jump over to the demo and start showing you some of the pieces that come into play here. So if we quickly break out what's in the demo topology, we'll essentially see that we're using OpenStack here, and OpenStack is running group-based policy. We're offering that policy automation framework as part of an OpenStack service. We use the Cisco APIC and the ACI fabric to do, again, the managed overlay and underlay environment. We have the Convergence controller that's managing network services, and we also tie together Avi to handle some of the load balancing functions. And we're doing this to, again, provision a multi-tier application with network services stitched together using group-based policy across several different tenants. So now let me show you the real environment in OpenStack. So as you can see here, as part of this demonstration, that we're actually looking at group-based policy. So group-based policy includes extensions for Horizon and Heat as well as the CLI. In this case, we're looking at our Horizon UI. So you can see here that we've added a new tab for OpenStack for group-based policy, which includes a definition of all the different groups that were provided. In this case, you can see a number of groups that are, that were created, again, as part of a service stitching environment, from the as part of the one Convergence integration. You can also see that we have different rule sets that are provided and consumed by these different groups. This defines the connectivity between the groups and also the policies by which these groups interact. Embedded in some of these different rule sets are service chains and implicit redirection through service chains. And I'll show you how that comes into play as we look a little bit more at how group-based policy works. If I dig across the different tabs here, the next tab we can see the groups, we can actually start seeing the application policies. These are the specific rule sets that we stitch together between the different groups to describe their connectivity. They include specific policy rules which allow particular kinds of traffic. In this case, some of the rules include redirection, in the case of redirecting traffic through different service chains. If we continue on here, we can actually see that we also have, again, separate from our application policies, but we have something called network and services policies. These allow us to define behaviors that are specific, that actually separate out the requirements of the underlying network. Say what what IP addressing scheme may be used and what VRF, and what bridge domain traffic may lie in. And we separate that out from the underlying application requirements and underlying application groups. You can also see here that we have a tab where we can directly define the network services, and you can see a number of network service chain specifications are defined. And these chain specifications essentially define sets of network services that could be stitched together between different groups dynamically, again by the one Convergence controller via group-based policy. So, in a second, I'll hand it over to Prasad to show you how the one Convergence piece works. Let me quickly show you on the APIC, what this looks like. So, as part of group-based policy plugin for APIC, we're actually dynamically pushing this policy into the into the APIC controller. So we're dynamically creating things like the endpoint groups, based on the policy groups that were created, within ACI. You can also see that the ACI fabric is again learning, the members of different groups here. So if we, for example, look inside one of these groups, we can actually see, different things we learn from OpenStack on our fabric as a result of the connectivity. We can also see inside here, the topology, the logical topology that was created by group-based policy describing the connectivity. This is all mirrored, as part of APIC. The last thing I'll quickly show you is, again, via our integration of ACI and APIC with the KVM hypervisor, we actually have a view of all the operational data that's going on in OpenStack, including the different hypervisors and the virtual machines that exist on them, as well as the different groups that are created. They can all be viewed, including health and stats, directly in APIC. So from here, I think I want to hand it off to Prasad and let him actually show you the one Convergence integration and piece of this puzzle.
Thank you, Mike. One thing I want to also kind of reiterate is that if you look at OpenStack GVP provides a framework for configuration and pull in multi-vendors and from various things, all the way from layer 2 all the way to layer 7, and the ability to automate is provided through the APIs. Now individually the operational model, or looking at it, Mike provided the L3 below, he provided excellent from an APIC model, pretty much the operational model, while I show from a network services side, we have the controller which basically now at this point rendered the 3 types of services, and now the operator can now come back and then do the whole lifecycle management through our controller. So here I show the dashboard of our controller, and you could quickly kind of see. So what we're providing here is a lifecycle manager for the service which was rendered through the policy. You can see, as you quickly see, there are 3 different types of services configured. One from a tap where the snot is configured, and then there's a load balancer which is being configured via HA proxy, and then that's a L3 type. and there's also a firewall in a L2 mode that's configured. The richness of ACI allows you to kind of configure various types of network services, while now where we overlay our services on top of it and provide the very composite kind of network services. And again, from a point of view, if you kind of drill down, so what we do is from here, what we're showing here is if you look at we provide not only the instance management, we also kind of collect all the statistics from various services and do a nice time series data across the statistics that can be correlated back into the logs. We have a fairly rich framework for collecting logs from various of these network services and correlate into a very rich kind of Elasticsearch framework where now you can kind of correlate both the stats and the logs and provide very rich analytics on top of it. This allows you now to kind of what we are showcasing here is all the way from the provisioning of the rich services, both from a automation model and from an operational model. We thank ONS for all the support they've given to kind of present this service provider operator showcase. Thank you very much.
Thanks a lot.